Hey Thinksters, and welcome to this video where I want to show you the Python list insert method. Okay, so how does it work? Basically, let's start with an example. Say we have a list 1, 2, 3, 4 of 4 elements, and now we want to insert the element 99 at position 3 into the list. Okay, so we can use the insert method. So we call it on, it's a method, it's not a function, it's a method, which means that you call it on a given object. And on what kind of object? On a list object, obviously. Okay, so we have a list object, we call the insert method on this object, and we insert it at a, so we want to insert at a certain position, at position 3 for example, the element 99. Okay, so what would you think? So how does it has no return value. The return value is none because it simply modifies an existing object. So we call it on the object, so it modifies the object, it modifies this list. And if there would be a return value, this would imply that it would have created a new object, which is not the case. So it doesn't create a new object, it just modifies it. So now what would you expect to see if we print the output of the list function to the share of the list object? Yeah, so we have at position 3, so it inserts at position 3 the new value in the new element 99. So we have position 0, position 1, position 2, and this was the previous position 3. And you see that the insert method inserts the element before the element currently at the given position. Okay, so and now if we have another example like list insert 1, for example, at position 99, say the element 42 at position 1, then the second element would be the new element. Okay, let's have a few special cases. So what happens if we have a negative index? So say 88, the element 88 at the negative -1 index. So here, this basically, you may already know it from Python slicing feature, that if you have a negative index, then you count from the right hand side. Okay, so -1 would actually be the same as the last index of the last element, the index of the last element in the list. Okay, so -1 is this. So yeah, this is our current list. So -1 would be this element 4. So if we insert something at this index, this means that we add the element before this index. Okay, so before this last element 4, we add the element 88, which means that 88 will become the second last entry of the list. Okay, and you can see it here. 88 is the second last entry of the list. Okay, so you can also have like insert -2, for example, which will make the element 77 the third last entry in the list, and you can see it here. And so this allows you to like control the insert behavior from the left to the right or from the right to the left. So you can like you can use whatever method you prefer, and makes your code more readable. Actually, both have the same performance, so you can really use either method of inserting elements, like the negative indices or the positive indices. And so then one special case is also if you have a very high, say, index, like index 100, and we want to add the element 66 and at position 100. What does it mean? The list doesn't even have 100 elements. So, but think about the semantics. It inserts the element at the before the position 100. Okay, so if you have if you don't have 100 position, then it will simply add the element to the end of the list. Okay, so you can see it here. 66 is just now the final element of the list. So it really, the insert operation, basically all indices which you can pass as an argument are valid. All integer values are valid arguments, which means that so you can have negative indices, you can even have very high negative indices like -166, which will just then insert the element at the beginning of the list. Okay, so you can have very high negative, you can have very high positive, you can have an arbitrary integer value, and all integer values are defined, so there won't be an error. So no matter which integer value you put in, it's a valid argument basically, and now you understand all valid arguments, the positive and the negative one. If the positive argument is too so if the positive index is too large, so it is an index that doesn't really exist in a list, it will just append it at the end of the list. If it is too small, so like too negative, like negative 1 million, then it will just add it to the first position in the list. Okay, so this is how the basically how the list operation works. It takes two arguments, the index and the element, and you can append an element. And yeah, so the complexity is linear because it like the CPython implementation takes an array underlying array list, and if you see, so let's show you some graphic. Okay, so it's very, so say we have a list here of elements, like here we have 1, element 2, and element 3. And now we want to insert an element. Let's add another one, 4. Now we want to insert an element at position 2. Now we don't have to traverse the whole list. We simply have to go to the element that's currently at position 2, which is this one. Yeah, so we simply go there, and now we say 99 is the new element which we want to insert before this element. This means that we take the pointer, the previous pointer that points to the position 2, and we let it point to our new element 99. Okay, so now this is the this is our next list element 99, and then we point from our list element 99 to the previous element at position 2, which was element 3. Okay, now 99 has simply replaced the position, but we simply have to modify 2 pointers, basically. Yeah, so we have to remove 1 pointer and add 2 more pointers. So we have basically 3 operations to add 1 element to the list. And now you see everything else remains the same. So basically, conceptually, the insert operation has constant runtime. No matter how large the list is. I mean, even if there would be 1 million elements more, so like I have the star operator indicates that there can be many more elements here before and after. It doesn't matter because we simply go to the position in constant runtime, in constant time. We go to the position where we want to modify. We modify 3 pointers, no matter how large the list is, and we have we obtain the new list, the modified list, with an inserted element. And yeah, as I already told you, like the insert operation, the return value of an insert operation is always none. So you can print list insert. So say at position 0 we insert the element 0, and you see the return value is none because we modify an existing list. We don't create a new list. If you want to create a new list and insert something, say you have the list 1, 2, 3. Or now let's call it like Anne, Alice, and Bob. So a list of 3 elements, and you want to insert another element at position 1, say. We insert the element Carl. So then we yeah, if you print it, so we have now inserted element Carl, and you see that it modifies an existing list. It doesn't create a new one, basically. Okay, so if you want to create a new one, then the alternative would be to, so I call the new one list 2, to simply use slicing. So we have list, we slice until the position 1, where we want to insert our new elements. And now we can even add multiple elements, like say Carl and Joseph and so on. And then we slice all the way to the right, starting from index 1, where we want to insert a new element. Okay, so now you see this is a list concatenation operation. So the plus operator, when used on list, simply concatenates multiple lists. It creates a new list that, where all the sublists are concatenated to a new list, which means that it's not as efficient as the insert operation or method, but it allows us to like even insert sublists conceptually into a given list. Okay, so that's it. So one note which was often asked, is it thread safe? And basically, yeah, in the CPython implementation, all these basic operators are thread safe because CPython doesn't execute all these like predefined operations in an atomic way. So which means that the operation, like the insert operation or append operation or all these list operations, they are basically executed wholly before another thread is allowed to grab the resources and to work on existing data. So there's a locking scheme which disallows any second thread to change the operation and to change the semantics of the operation dynamically. So when another thread is currently working on this resource. So, and the list is simply a resource object, so you cannot, so like there's no way another thread can concurrently modify a list if another thread is already working on this list. Okay, so there's a locking scheme, and CPython implementation basically makes all basic operations that are defined in CPython are thread safe, so you can safely use them even in a multi-threaded environment. Okay, thanks for listening to this video and see you in the next video. Bye.